Hello everyone. Today we have privilege speaking with Professor Michel Mayo, whose extraordinary discovery of exoplanet led a new door of cosmos discoveries. He is also a 2019 Nobel Prize winner in physics. So Professor Mayo, welcome to the show on Doordarshan.
Thank you very much for the invitation to discuss with you. I'm so glad to be here at the time of a very important conference here with a lot of colleagues from different countries discussing this kind of matter.
Okay, Professor Mayo, I would like how was your childhood? Like, from where does your romance with stars and planets in sky begin?
In fact, when I was a child, I was really interested in science, but not specifically astronomy. So, not far where I live in, I remember a mountain with a very important shape like this, because the force between the different continents, and so it's exciting how it's possible to do this kind of change of the mountain. So, and then after I was interested in different domains of zoology, botany, and so on. And then after I start, evidently you have to choose after the high school, and I start to do theoretical physics because I was really fascinated by the elegance of the theoretical physics. So I did study in physics, and I start during my first research to interaction of particle with large spin, so nuclear reaction, nothing to do with astrophysics. And then after I start a PhD at the Geneva University in the field of, okay, it's a little bit technical, but I will explain. What is called a density wave. You can, when you are looking beautiful pictures of galaxies, you see frequently the shape of the galaxy as two arms.
Okay.
And until 1963, nobody understood how it was possible, because the size is terrific. The light will need 100,000 years to go through. So what is the physical process to explain this? And some colleague of US, Professor Lin and Professor Shu, gave the answer. It's a kind of wave.
Okay.
So it's not matter. And then after this opened a lot of marginal questions, and I did my PhD in that field. So that wave is supposed also to slightly modify the motion of stars surrounding the sun. So this is, at the end of my PhD, it was purely theoretical. So I decided, I need to measure the velocity of stars to prove if what I did is correct or not. And then at the time, it was awful. Measure the velocity of stars, it's an old technique, it was boring, inefficient, and so on. So I said, I will not do these things. And by chance, always you have in your life, you have some moment where you have some chance. And at some moment, I met in Cambridge, in England, a guy, a young astronomer, developing a new kind of technique. And for me, I fall in love immediately with the idea. So this instrument was not fantastic, and it was easily imagined that we can do something better. So when back in Geneva, I asked the permission to the director of the time to develop this instrument, and it was a dream. Okay, it's controlled by computer. You have almost nothing to do. Everything is made by the instrument. And just to have one value, the gain of efficiency compared to the old technique was 4,000.
Oh.
So it's incredible. You can start to do what you want. Every domain you can. It's so easy. So it was a very good moment in my career to decide to do instrumentation. Okay. And this was the start of a long life of development of different generation of instruments like this to measure the velocity of stars. It was a clever idea made by an English astronomer a long time ago. And so, and today everybody uses only this technique.
Yes.
And then after, generation after generation, we understood what was not perfect. So one generation in the early 90s, we built a new spectrograph called LOD, and it was installed to a 2-meter telescope in south of France, and suddenly it was a miracle because the precision was 10 meters per second. So you can measure, let's say, if you have a bike,
Yeah.
you can measure the velocity of the bike or something like this.
Yes.
So, and I decided immediately, I will not continue to what I did before. It will be stupid. You have something much more precise. What is the best thing to do?
Yeah.
And search for planet. So it was relatively late, and it was driven by the technology, because we did a very important step in the precision. In fact, this is okay, what we can do. And immediately after a few months of measurement, we have a first planet.
Okay, so whether this 51 Pegasi B was an accident, serendipity, or you thought it will come in your way of your journey?
No, not really, because previously with the old spectrograph, we have selected a sample of 142 stars like the Sun,
Okay.
and not part of binary stars, because you know a large fraction of stars are part of a double star. So we have decided to not to complicate the story, so to take only single stars, and it was not serendipity. We measured the velocity of the first one, the second one, the third one net, let's say 30 measurements during a night, and the night after we repeat, and so on, and 1 week after we repeat, and 2 months after you repeat, and so at no moment you say, yes, we have a planet. It's only when you have a long series of measurements made during several months that you start to see that one set of measurements for one planet looks to be periodic. What is the possibility? If a star is moving like this, it's not without any reason. You have to find the reason. You do some very simple calculation, and it is a Jupiter-type planet, but with a period of 2 days. No, 4 days, 4.2 days. Crazy. The theory predicts that giant planet cannot have a period shorter than 10 years. Jupiter, something like this, Saturn, 30 years or so. So you have a discrepancy with the theory by a factor 1,000.
Yeah.
So if you do not want to be ridiculous, you have to be a little bit.
So I would just want to be in that moment only. Like I remember Copernicus suddenly, like when he said we are not the center of the universe. So same like the old theories were really broken. So I think you and your companion, your colleague would be the only person who would be believing like this kind of planet so close to star is existing.
Yeah.
With this. So were you not in doubt? Were your confidence less to like speak, and what if we speak and if you get it wrong? What was those times, if you can recall, the conflicts that went into your mind, or those nights and days, if you can recall? Yeah.
What are the other explanations? If you have a star with magnetic field, with big spots rotating like this, the apparent velocity of the star will change. So it could be not a planet, but the rotation of a star with a magnetosphere. So the second possibility will be, we know that a lot of stars are pulsating. Is it a pulsating star or not? So we have made new observation to exclude the pulsation. And if it is spots, you know the spots on the sun do not live several years. So we were expecting some change. And in July, the year after, we have remeasured the star, nothing changed, the same period, the same amplitude, the same phase. So I just finally say, what we can do? It's the only reasonable explanation is an object. I don't know what it is, but it looks an object. And we publish it in the paper Nature. It's a relatively important paper.
Yeah. So, if you recall those days, so how did then our understanding of sky and cosmos, the way we look at the sky, has changed completely?
At the moment, we are only focused on to analyze our data and to be sure that it's not something related with the instrument, if it's not another physical phenomena, and so on. So it was not the time of the philosophy.
Okay.
It was the time of the real things.
Yes.
And so on. And then after, we announced the discovery in October 95 in a colloquium in Italy, in Firenze, and it was the moment everything changed. Overloaded by television, by journal papers, and so on. And it was, I don't know, a dozen and dozen and dozen. And so we realized we have put the finger on something not habitual, not usual. And after we say, okay, with Didier was my student.
Okay.
And we say, oh, okay, 2 months we will answer kindly to journalists. And in 2 months, okay, everything will stop and we will continue to do research as we did every time. And this never stopped. It's the reason why I'm here. No, this never stopped.
Yeah.
Because in early 96, our colleague from California announced the discovery of 2 planets. And so on and so on. Always you have new things. And then evidently today we still have a huge interest because you have space mission, you have a lot of space mission. It's very at the top priority of agencies, NASA, ESA, and so on. It's so you have a huge amount of people working in different institutes, biologists, chemists, physicists, astronomers, and so on, geologists, to analyze the next big questions, à savoir, do we have some form of life on some of this planet? And I need to mention something from the past. The Greek philosopher, more than 2,000 years ago, was extremely concerned with the possibilities that we have several worlds in the universe. It was not planet, it was a more philosophical question. And his very famous letter, Epicurus mentioned on some of this world we have living species, but not on others. So it's fantastic to imagine this man discussing this matter more than 2,000 years ago. It was philosophical question, not planet. Yeah. And it's only during the end of the 16th century that after Copernicus, that Giordano Bruno was not a scientist, he was a monk, maybe with some special idea. So, but he said something so simple. He said, the sun is a star. It's only brighter because it's closer. For us, it looks very simple.
Yes.
It was not evident at all before. Yeah. And he said, if you have planet orbiting the sun, so we should have also planet orbiting star. So it's no more the philosophical question of worlds, it was really planets. Okay, he paid very heavy price for that because he was burned, killed by the church in the early 17th century. And then this was really, it was very simple. It was just a few sentences. But I believe it's a change. And it's very interesting to see that already during the 18th century, you have some atlas of astronomy that the people producing these beautiful drawings show that distant stars are surrounded by planetary system. So it was quite accepted by all people. it was something, okay, it's normal. We should have. And it's very strange because if you are a little bit fast in this story, at the beginning of the 20th century, so not so far, the general feeling, estimation of our colleague astronomer, very big names, Sir Jeans in Cambridge, Shapley, Harvard, and so on, estimate that we are alone in the Milky Way. 200 billion of stars, and we are alone. Okay, it was based on the Ernest theory, and then after the idea changed in the middle of the 20th century, and suddenly, immediately the idea jumped to billion, hundreds of billion of planets. Almost every star should have planet. Okay. So it's not so. It's interesting to see that these ideas are not so old. I was already living when this change was appear.
Yes, it just reminds me of Galileo when he just took the telescope towards the Saturn, and he felt like these rings are like Saturn's years, and like the kind of excitement and joy that he might have felt, I feel that you might have also felt looking at the exoplanet. But I just want to take you to your days in France, the Haute province. The observatory that you were doing around like the I think 1.5 meter telescope. From that, now we are moving towards around 40-meter telescope, extremely large telescope that we are going to set up. So entire range of technology has changed in this time. So how do you see the journey of this instrumentation, journey of all these observational techniques and technology, whether it is like TRAPPIST or whether it is the Kepler mission or James Webb?
Yes. Yeah. Yes, it's true that if this domain was not considered to be priority before 51 peg, after it was completely changing. A lot of new instrumentation, new big observatories start to do systematic measurements. And in Haute-Provence, we have not only discovered 51 peg, but several others. But you know, the size of the telescope, the quality of the skies was not absolutely the best we can dream. And so we have decided to develop a new instrument to put in the southern sky in La Silla, in Chile. The sky is beautiful, it's a desert and so on. And so we start a very huge program of to search for planets in the southern sky. And not only us, you have the American have made something in different places, Hawaii, and so on. So it was, and today, here in Ahmedabad, the PL joined the club.
Yeah.
Yes, they have developed a new instrument called PARAS-2, it's an acronym, and this is a spectrograph. And what is very special, that it has the capability, the precision to measure 0.3 meters per second. Okay. So 0.3 meters per second change is something like when you are walking. Yeah. So you are measuring the velocity of a star quite distant, and you are able to see change of the velocity at this level of the velocity of a layman. So I'm very happy to be here because to see some colleague joining the club of people having this capability to search for planets. Sky is big, so I don't see any competition. Yeah. We have several observatories have developed something similar. So you can see the sky. You have plenty of work for everybody, and still more with a future satellite, because in 2 years, I believe from now, ESA will launch a new satellite called Plateau, and with the capability to measure, to search for planets, to analyze the age, the mass, and so on of stars. So it's thousands of stars. So it's good if you are several to measure, because the radial velocity is technique, my own technique, it's comment dire, really chronophage, need a lot of observing time. You need a lot of nights, a lot of, so it's good if you are several to do it.
Yeah, as you talked about India and Ahmedabad, as we are talking in this physical research laboratory, I would like to ask, India has a very much rich legacy in astronomy, particularly observational physics as well, observational astronomy as well. So, how do you see India's contribution to the world in ancient times as well as in current times?
So, okay, at the beginning, just after the discovery of 95, of history, we have some tension between some colleague in US. So it's a part of the ego of people. It was we feel a relatively strong competition. Today it's no more the case. We have more than 5,000. So we not fight between us if you have one, and so on. So, and you have so many questions to find, because what we have discovered during the last 25 years is that the huge diversity of planetary systems, they are not similar to our own solar system. Some of them, yes, yeah, but you have many planetary systems very different. So it's interesting first to understand the formation of our own planetary system. Yeah. And evidently, again, this opened the field of the search for life in the universe. Yeah. I don't know. Don't ask me when we will have the answer. Or I don't know. It's a very complicated matter, but it's very interesting, because what is behind? It's a philosophical point. Okay, are we alone in terms of species, of form of life, alone in the universe, or is life, I would say, a normal process? Yeah. So when you have some good condition, okay, not on every planet, but on some of them, if you have the good condition, is life suitable to appear? Okay. Nobody knows. So this is a work for the next generation.
નોબેલ પુરસ્કારથી સન્માનિત પ્રોફેસર મિશેલ માયો સાથે સંવાદનો ભાગ 2 નિહાળો આવતા શનિવારે બપોરે 2 કલાકે માત્ર ડીડી ગિરનાર અને અમારી યુટ્યુબ ચેનલ ડીડી ન્યૂઝ ગુજરાતી પર.